Hello, this is the test review for the test retake that will be on Wednesday, November 6th. So right now we're on version B, which you should have marked up on your paper, so there should be no confusion about what version we're looking at. So we're going to walk through this, through the video. Feel free to make the speed of the YouTube video faster or slower, but we'll take our time. So for describe the end behavior of each function, we could go in and just graph this and see what it looks like graphed, or we could try to use that table that said if it's even or odd, and that's based on the degree, and if the leading coefficient is positive or negative. So remember, we said if it's even and positive, it'll act like a parabola. If it's even and negative, it'll act like a parabola that's facing down. If it's positive and odd, it'll act like a positive line. And if it's even and odd, it'll act like a negative line. So when we look at this, if it's an even degreed polynomial with a positive leading coefficient, it's going to have as x goes to infinity, y is going to go to infinity as well. As x goes to negative infinity, y is going to go to infinity. So notice how the ends match. Likewise, if we do this for the negative parabola, our y is just going to go to negative infinity. X goes to negative infinity, so the left, y goes to negative infinity. The end behaviors match. For an odd degree function, the end degrees are opposite. So as x goes to positive infinity, y is going to go to positive infinity, because as we go to the right, we go up. As we go to the left, y is going to go down. For a negative odd function, as x goes to infinity, y is going to go to negative infinity, because as we go to the right, we go down. As x goes to negative infinity, y is going to go to positive infinity, because as we go to the left, we go up. So if we look at number 1, we're saying the degree is 4, so which makes this even. And our leading coefficient is -1, so that makes it negative. So we are going to, and this is a new feature, we are going to use, we have even, negative, so we are going to use this one right here. So when we go back, it's going to kind of act like a parabola that's upside down, even though it's degree 4, so that means it probably is actually going to have some humps in there like that. But that means we want, as x goes to infinity, right, and we said this before the test, as x goes to infinity, y is going to go to negative infinity. So this checks out. As x goes to negative infinity, y goes to negative infinity. So that's why A is the correct answer. Likewise, if we look at number 2, our degree is equal to 3. Our leading coefficient is 1. So that means we have an odd function with a positive degree. So that means we are going to act like, let's see, here's odd and positive. So we're going to do this one right here. So we are going to go, as we go to the left, as x goes to negative infinity, y is going to go to negative infinity. As we go to the right, x goes to positive infinity, so y goes to positive infinity. So again, A is the correct answer. For number 3 and 4, we're looking at the maximum number of turns, aka turning points. Turning points is always equal to the degree minus 1. So we're just looking at the degrees in this function. So we do 5 minus 1 equals 4. 3 minus 1 equals 2. Alright, that was number 3 and 4. Number 5 and 6, the possible number of real zeros, the max. So I kind of walked around and talked about this, and I said, don't worry about all these other things here. Alright, and the maximum number of zeros is always just equal to the degree. So our degree here is 4, so the correct answer was B. Our degree here was 5, so the correct answer was B. So for this one, the way that it was written was kind of weird. What this is saying is if we ever have an imaginary or complex 0, they come in pairs. So that's why we go down by 2. So number 5 could be 4, 2, or 0, because we do 4 minus 2, which is 2, and then minus 2, which is 0. All right, find all roots. So if we look at numbers 7 through 10, we're all finding the roots, but we have to use different methods. So for number 7, finding the roots means we have to factor. Here we can't take out anything from each term, so let's try to group. If we try to group, we could take x squared out of each, so we get x plus 3. For the next one, we can try to take negative 4 out of each, and we get x plus 3. So when we group, we get it. We get x squared minus 4 and x plus 3. And then we set each one equal to 0. So here we get x squared equals 4. So x is equal to plus or minus 2. Here we just get x is equal to negative 3. So that means the correct answer is A. And again, this is because we take the square root, and whenever we take the square root, we get plus or minus. On the next one, if we try to do the same thing, if we try to group, we get x squared times x minus 4 minus 2x minus 4. So it worked. Cool. All right, then we set each one equal to 0, so we get 4. So that rules out, excuse me. So that rules out B, but then we have to deal with this. We get x squared equals 2. And then we take the square root of both sides, so we get x is equal to plus or minus 2, so 4. So remember, we only get I when we have a negative inside the square root. Let's move on to the next one, number 9. We don't have 4 terms, so there's no way to group, but we can see in each term we can take out an x. So because of this one right here, we know x is equal to 0, and then we can say this other whole term is equal to 0. So we need these zeros here. Can't rule anything out yet. We can try to factor this. We need 2 numbers that multiply up to negative 10 but add up to 2. The only factors of 10 are 5 and 2. There's no way to make those add up to 2. So we have to use our quadratic formula. So that says, there once was a negative boy who couldn't decide to go to the radical party. The boy was squared. He missed out on 4 awesome chicks, and it was all over by 2 a.m. So we do negative 2 plus or minus the square root of 2 squared minus 4 times 1 times negative 10 all over by 2 times 1. So negative 2 plus or minus 4 plus 40 over 2. And I'm going to come all the way over here. Negative 2 plus or minus 44 over 2. Notice how we have square roots in our answer choices or i's. So then we can try to simplify this. We get negative 2 plus or minus 4 times 11, which is 44. So negative 2 plus or minus 2 times the square root of 11 over 2. And we can actually deal with this 2 now. We can divide it out in each of these terms. So we get negative 1 plus or minus the square root of 11 over 1, and that part just disappears. So for this, we get answer choice B, because they actually split up that plus or minus. Number 10 is similar. We can take an x out of each, right? So here, that's all we can do. This turns into x equals 0, and again, we see that all here, so we can't simplify or cancel any options out. But now we have to set this equal to 0. Again, thinking of factors that add up to negative 4 but multiply up to 20, there's nothing, so we have to use our quadratic formula. So we do x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So we do negative b, so that turns into positive 4, plus or minus b squared, so negative 4 squared minus 4ac all over by 2a. So 4 plus or minus 16 minus 80 all over by 2. 4 plus or minus 16 minus 80 is 64, but negative all over by 2. 4 plus or minus 64 is a perfect square, but then that negative in there, so that turns into 8i all over by 2. And again, we can simplify this 2 out, so we get 2 plus or minus 4i. So now if we look at our answer choices, the only one that looked like that was D. All right. Number 1112 is the rational root theorem. This one was just taking all the factors of all the factors of the last term and divided by all the factors of the first term. So that means all the factors of 50 divided by all the factors of 1. So that's 1, 2, no 3, no 4, 5, 6, 7, 8, 9, no 10, yes, 25, 50. And the only factor of 1 is 1. So that's how we get plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10, plus or minus 25, plus or minus 50. B. Next one, again, last term, all the factors of 25, which are 1, 5, 25, divided by all the factors of 3. So 1 and 3. So we get plus or minus 1, plus or minus 5, plus or minus 25. And then we get plus or minus, it's kind of get confusing, but 1 over 3 plus or minus 5 over 3 plus or minus 25 over 3. There's nothing to clean up here, so that's how we get C. All right, moving on to 13. I give you 1, 0, so if we want, we could try to synthetically divide here. So that would be 3 in the box, and then we get 3, negative 8, negative 6, 8, 3. And then if we do synthetic division, we carry down the 1. And then multiply, so 3 times 1 is 3, add them up, negative 5. 3 times negative 5 is negative 15, add them up. We get negative 21. What? I'm doing something wrong here. That's how I got started, right? Ooh. I am blanking about how to do synthetic division. So this is a good example of where if you just forget on the test, that's when we go to graphing. So we have 3x to the 4th minus 8x to the 3rd minus 6x squared plus 8x plus 3. So this is the graph that we could have gotten a graphing calculator. Again, I'm not going to try to use the Desmos features here, but we can kind of see that it looks like it crosses at -1, some number in between 0 and -1, some number at 1, and then at 3. So if we go back, we said again, -1, something in between -1 and 0, and then we said 1 and 3. So the options then become narrowed down to just D. But if we wanted to figure out that answer, then we have to use synthetic division. And just give me a second to be silent as I try to remember what I did wrong here about why I can't get the answer. Okay, so we said 3 is a 0. So then we put it up there. Oh, we don't carry down the 1. We carry down the number. Right. So 3 times 3 is 9. Add those together, we get positive 1. 1 times 3 is 3, so we get negative 3. Negative 3 times 3 is negative 9. Add those up, we get negative 1. Negative 3 times 3 is negative 3, so we get 0. All right, we know the next one, again, just from our graph, was negative 1. So again, carry down the 3, and then we do this again. All right, we get our 0, we're good. That means next we want to use, we use negative 1, now we can use positive 1. Carry down the 3. So we get 1, 0. So now we're left with this, which means 3x plus 1 equals 0. So then we get 3x equals negative 1. So then x equals negative 1/3. Let's try that again over here. We have 3x to the 4th, and this time we're going to graph it right away. 3x to the 4th minus 14x to the 3rd minus 8x squared plus 14x plus 5. So again, looking at this, not trying to use Desmos's tools, we have negative 1, positive 1, and 5, and some number in between 0 and negative 1. So we said negative 1, some number in between 1 and 5. So if we look at our options here, I see negative 1, negative 1, negative 1, 5, 5, and 1. All right, so this one is the only one that has all 3 plus a 4th one that is in between 0 and negative 1. But again, we can use synthetic division to make sure that it's negative 1/3. So we have our first root, which is 5. And then we have 3, negative 14, negative 8, positive 14, and 5. So we carry down the 3. We get 15. We get negative 3. We get negative 1. And we get 0. So then again, because we knew these 3 options, the next one we could do could be 1. So carry down the 3. All right, and then we have negative 1 as our last term that we can see clearly from our graph, and we could have gotten that with our rational root theorem. Carry down the 3. So again, we get 3x plus 1 equals 0. So 3x equals negative 1, so x equals negative 1/3. So that's again why we get A for our answer. All right, so next one, 15 and 16, write a polynomial function in standard form using the list of zeros provided. Don't forget all about the conjugates if applicable. So if these are our zeros, that means our roots would be x minus r0, and x minus r0, and x minus r0. So that would mean we have x minus negative 3, so plus 3, x minus 5, and x minus 4. So we have to actually distribute this out. So, and we can only FOIL 2 terms at a time, so we're going to get x plus 3. And if we do FOIL, we're going to get x squared. Outer, we're going to get minus 4x, then minus 5x for inner, and then plus 20x. Let's clean that up just to save our brains. All right, so then if we distribute now, no longer FOIL, so let's keep track of what we're doing with our arrows. We get x cubed minus 9x squared plus 20x, and then the next set we're going to get, and I like doing this, adding them up with like terms lined up. Okay, forgot the x there. So we get 3x squared minus 27x and then plus 60. So we get x cubed minus 6x squared minus 7x plus 60. So that's why C is the correct answer. For number 16, it's a bit more difficult because we have this complex number, and that's where this conjugate comes in. If we have 3 plus I, that means we also have the conjugate, which is where we switch that inside operation. So we always get this third, this separate 0. So we still do the same process. X minus our 0, so x minus 5. X minus our 0, so x minus 3 minus I. And then x minus our last 0, so x minus 3 plus I. It's going to be easier to deal with this first. It doesn't look easy, but it's just easier to deal with it first because things tend to clean up. So I'm not going to write that right now. So we do x times x squared. X times negative 3x. X times I, which is plus xi. All right. We do negative 3 times x. Negative 3 times negative 3. And I didn't have a whole number, so I just skipped that. Negative 3 times I. All right, and then lastly, negative I times x. Oops. All right, negative I times 3, negative I times negative 3, and then negative I times I. All right, so now if we try to add these all up, we get x squared minus 6x, these cancel, and then minus I squared is actually just minus negative 1, so plus 1, and 9 plus 1 is 10. So we got rid of all our i's because those were conjugates. So now we have this x minus 5 here. So now we have to go back to just distributing again. So we get x cubed minus 6x squared plus 10x, and then we get the other ones, so negative 5x squared plus 30x minus 50. So if we combine like terms, x cubed minus 11x squared plus 40x minus 50. All right, so that's how we get 16. 17 is just more factoring, kind of like what we did on the other side. But here we have maybe some more complex work. In this one, I see we can take the x out of everything. So that's how we get these. So then we now just have to kind of factor x cubed minus 5x squared minus 4x plus 20. The first thing we should try to always do is group. So then we get an x squared out of all this, and then x minus 5, and then minus 4, and then it is x minus 5, so that's awesome. So x squared minus 4 times x minus 5, and the x on the outside. We don't have that as an option because we can actually factor this a little bit more. That's the difference of the squares, so we get x times x plus 2, x minus 2, and then x minus 5. So if we check, we definitely didn't have that, we didn't have that, and we didn't have a 3. So the correct answer is D. If we move on to the next one, if we try to do the same thing, there's nothing we can take out of each, but we can see, can we just group it right away? And in that case, let's see, we get x squared out of the first two terms, 4 out of the last two terms. We get the same thing. All right, and that's why we got the x plus 5. But now we have to see what can we do with this. We don't have a difference of squares here. So we actually have to use some of our knowledge here. We have x squared plus 4 equals 0. So x squared equals negative 4. And we take the square root of both sides. We get x is equal to negative 2i. Not negative 2i. Plus or minus negative 2i. So if we look at it, those are our two factors. So we're going to do x minus 2i and x plus 2i inside our factored form. So that's how we get C as our answer. The last set of problems, we have to solve this inequality. So I already had it factored for you. So what we're going to do is set up this number line to think about it. This is our factor, so which means our 0 is negative 3 and 4. All right, so if we look at this, we want to figure out where this is less than 0, which means negative. We want to plug in some number to the left of negative 3. Let's just say, let's plug in negative 4. If we plug it into our factored form, we get negative 4 plus 3, which is a negative, times negative 4 minus negative 4, which is negative. So we plug in negative 4 and we actually get a positive. So this is not in the solution set. A nice little number in between negative 3 and 4 is 0. So if we plug that in, 0 plus 3 is a positive. 0 minus 4 is a negative, so we'll get a negative here. That is in the solution set. And then if we plug in a number to the right of 4, we get 5 is a good example. So 5 plus 3 is 8, which is positive. And then 5 minus 4 is positive. So then we get a positive number, which is not in the solution set. So we want to somehow say this interval, right, where x can be between negative 3 and 4. So these are not correct because that's not the in-between. What then we need to decide is, do we want the parentheses or do we want the brackets? And that's when we have to come back up to our original problem and look at our inequality. This inequality is just less than, so we're going to go with our parentheses. If we had less than or equal to, that extra bar turns it into a square bracket. We must remember that. All right, 20, same setup. We have, and then we take the opposite signs of all of these. So we have negative 3, 3, and 6, and then we take some numbers that are nice. So like negative 4, 0, and 4. I just like smaller numbers, but you can choose whatever. So we go in negative 4 minus 3 is a negative. Negative 4 minus 6 is another negative. Negative 4 plus 3 is another negative. So 3 negatives together are negative. We want greater than or equal to 0. So this is not in the solution set. At 0 minus 3 is a negative. 0 minus 6 is a negative. And then 0 plus 3 is a positive. So these three, we have 2 negatives, 1 positive. That would all multiply up to a positive. And that is in the solution set. 4 minus 3 is a positive. 4 minus 6 is a negative. 4 plus 3 is a positive. And those would multiply up to a negative, and that's not in a solution set. And then we have one more little interval, which would be to the right of 6. So for example, 7. So 7 minus 3 is 4, and that's positive. 7 minus 6 is a positive. And 7 plus 3 is a positive. So altogether, that would be a positive, which is in the solution set. So we have these two intervals. So we need 2 pairs of brackets. So A is out of the question. We want the number in between negative 3 and 3. And we want the number... right? We want this interval, and then from 6 all the way to the right, which would be to infinity. What we need to say is, because of this inequality, do we want a parenthesis or bracket? Because it has that extra thing at the bottom, that would be a bracket. But infinities always take the parenthesis. So we try to look at which one it is, and that would be B, because we see those square brackets. So hopefully that helped you on your test. I think I will have time to do version A, so make sure, if you want, you can try to do some version A questions on your own first, and then check the answers and see if you get it.